Hi, this lesson is on polynomial inequalities. So let's get started. The first thing that we're going to do is a little warm up on how to solve a polynomial. So let's try to find the roots for this equation. You are going to use the rational roots theorem to find the factors that might go into 12. And remember, this value here is your p of x. The value here, which is 1, is the q of x. So if you're looking at the coefficients, so remember, all the values that I might try to factor into 12 would be plus or minus 1, plus or minus 2, plus or minus 3. These are all the factors of 12. Plus or minus 4, plus or minus 6, and plus or minus 12, divided by plus or minus 1. And so this is your p of x divided by your q of x. And all this does basically is it tells me the different values that I could divide into this polynomial equation. So the first thing I'm going to try is synthetic division. So we're going to go 1, negative 2, negative 7, 8, and 12. And I'm going, sorry about that. And we're going to find a value from my rational roots theorem to plug in here. And so I'm going to just start with 2. Let's try 2. Adding down, multiplying across, adding down, multiplying across, adding down, multiplying across, adding down. What is that? 2 negative, and that's negative 4. So that didn't work. So we're going to try another number. And this time I'm going to try negative 2. Let's see. Let's try negative 2. And so we're going to add down 1, negative 2, so that's negative 4. Multiplying, I get 8, 1, negative 2, which makes 6. 6 times negative 2 is negative 12, so that worked. Yay. So now we have x plus 2 is one of my roots. So now I'm going to keep factoring. And now I'm going to plug in 3 or negative 3. I'll start with 3. Okay, so take this numbers 1, negative 4, 1, and 6. Add down, multiply across, add down, multiply across, add down, multiply across, I get negative 6. So I found another 0. So that's going to be x minus 3. I'm going to see this is what's left. And this comes from, you have your x squared minus 1x minus 2. And that actually is going to factor. And so I don't need to use synthetic division because I can just factor that. That's going to be x minus 2 and x plus 1 multiplies to be negative 2, but adds up to be negative 1. So the rest of my factors are going to be x minus 2, and you have x plus 1. And then you could just put these in ascending order into that area right there. So what this whole section is about is what we call polynomial inequalities. It's actually pretty important. And when you're solving a polynomial inequality, what they're actually asking you to do is to find where a particular graph is either greater than or less than 0. That's what they're asking you. Where are all the values that are greater than 0? So for this problem, the first thing I would do is I would put this in order and standard form. So x to the 5th, move these over. So that's going to be minus 3x cubed minus 8x squared plus 24 greater than 0. So what it's asking me is I have a polynomial equation right here, and it's asking me, where is my graph? It's asking me, where is my graph greater than 0? So they want the interval. They're looking for the interval that makes the equation true, or in the inequality true. Looking for the interval that makes the inequality true. That's what they're looking for. So I graph this on my calculator just to start off. And when I graph this on my calculator, what you see is this graph that goes down, it goes up, down, comes back up. And of course, I graphed it here on my calculator as well. So what's happening here is this question is asking is this. See this value greater than 0? That's asking you where on my graph is x greater than 0. And so what you would do is you would look and you'd say, well, it looks like it's greater than 0 here, right? That's where it's above x equals 0, but also here. And this actually goes on forever over there. So you would say that that is equal to 0 from this root to this root, and from this root to infinity. And so that's what it's asking for. It's asking for the interval where it's greater than 0 in this case. It's not always going to be greater than 0, but in this case it is. So polynomial inequalities, this is just sort of like the rules to solving them. So for the rules to solving the inequalities, basically the first thing you should do is you should isolate the variables and or you should isolate the inequality, set it equal to 0. Set equal to 0, okay? The second thing you should do after you set it equal to 0 is to factor. The third thing that you're going to do, or the third step that you're going to do after you factor, is you're going to do sign pattern testing. Okay? And the other thing you're going to do is you're going to answer the question, what's the interval? Because that's actually the big question of the day, is what's the interval? That's what I want to know. I don't want to know a picture of the graph. I don't want a picture of the graph. I mean, although that's going to help me to solve it, but I actually want to know what's the interval that makes the equation true. So we're going to start off with this problem right here. And on this problem, okay, what you're going to see is I have already given you an equation, and I've also already factored it for you. And we're going to solve this one by graphing, okay? So finding the solution to what makes see this greater than, I want to know what values make this equation true. And the equation is this is greater than 0. So you're asking yourself where, and where meaning what's the interval. Okay, so where is my graph greater than 0? That's what I want to know. That's the question. So you find the roots, you can solve for 0, set them each of these equal to 0, and you end up getting -4 is a 0, +2 is a 0, and you also have +7 is a 0. Now, you know this, we just did a whole chapter prior to polynomial inequality, prior to this chapter on end behavior and graphing polynomials. And you should know that this is x cubed. This is a cubic because it's x times x times x. It's a cubic, and the end behavior, because it's a positive cubic, is right up, left down, meaning my graph is going to go up this way and down that way. And so what that's telling me also is it looks like my graph dips down like this, goes up, and comes around. So it looks like it goes down, comes up, somewhere up here, turns around, and goes down. So this is the graph for this equation. I mean, it's not completely accurate on how high it goes. We didn't put the y-intercept in. We didn't put a point here to see how low it goes. But what's important is that you see that my graph has been divided into 4 parts. And so you've got this part here, you have this part here, this part, and you have this part. So you have 4 intervals, and these are your intervals, okay? I want to know which of these intervals makes my equation true. So my equation says this: where is my graph greater than 0? So my graph is greater than 0. Here's 0. This is x equals 0. Here and here. So that's where it's greater than 0. So what you're going to do is you're going to write that as your answer. That's your interval. So your interval is going to be from -4 to 2 union 7 to infinity. And then that's the answer. I'm looking for the interval. That's it. That's all I have to do. So instead of using my graph, I want you to use sign pattern testing. So we have the same equation that we just did. So we already know what the graph looks like. But what I want you to do is put your roots on this line. So we're going to go, that's -4, here's 2, and here's 7, all right? And now you're going to do a test. You're going to pick a number. Personally, I always choose 0. Okay, I always choose 0. 0 is easy to plug in. You get an answer fairly quickly. It's a good choice. So if I were to plug 0 in, that's going to be in between here and here. So this is the value of 0. Okay, let's plug that into our equation. So if I plug 0 in, I'm going to get 0 plus 4, which is 4. 0 minus 2 is -2. 0 minus 7 is -7. And this is what you're asking yourself. Is that greater than 0? So you have -8 times -7, which is 56. The question is 56 greater than 0? And the answer is, 56. And the answer is yes. So therefore, between here and here, this is true, meaning my graph is greater than 0 here. And now, so that's the answer for that. Now, where the pattern comes in, okay, is that there's a pattern to this. It's always going to be plus, minus, except one instance, and that's when you have your multiplicity is 2 or an even number. So when it's tangent to the graph, it bounces off. That's where it's not going to be positive, negative. So this is plus, there's minus, here's plus, that's minus. So it's going to be whatever your value is that you get. The other values are just going to kind of fall into place because that's the pattern. So the question is that where is my graph greater than 0? So it's greater than 0 here because this is true, goes down, comes back up, and it's here. So you would say -4 to 2, union 7, and then to infinity. So again, that would be my answer. That's my sign pattern testing. Okay. So, and this is the graph, which we've already done. So let's try this problem right here. You're supposed to solve this, write the answer in interval notation. So this is already set equal to 0. So the next thing I'm going to do is I'm going to factor. So factoring this, I get x plus 2, I get x minus 1, and that's greater than 0. Okay, I'm going to draw my line here, and I'm going to put my roots on this. So I'm going to go, well, I have a -2, and I have a positive 1. And so what this is going to do for me is I'm going to test now. I'm going to test the value. And again, I always choose 0. So I'm going to choose 0. 0 is in between here and here. And I'm going to plug it into my point. So you choose a point, okay? You choose a point, and then you plug it in to your equation, all right? You plug it in. So I'm plugging that in. I get 0 plus 0. So 0 squared plus 0 minus 2 greater than 0. So you're asking yourself, is -2 greater than 0? Yes or no? So -2 is not greater than 0. So this is false, meaning if -2 is not greater than 0, it's less than 0. Okay, so basically this is a minus, that's a positive, and that's because this is false, all right? And then this is true. So now what you have is your sign pattern test. You sign pattern tested it, and now you go back to the original equation. You go back to the original equation, and the original equation is asking you that right there. That's what's important. Where is my graph greater than 0? So at the very end, you're asking yourself, where is your graph greater than 0? So I'm going to go back to my picture here, and I'm going to go, wow, it's greater than 0 here, and it's greater than 0 here. So then my interval that makes my equation true would be -infinity to -2, union 1 to infinity. And that's the interval, and that's your answer. Box that up, that's the answer. Okay, let's try this equation right here. And again, this isn't set equal to 0, so we're going to do that first. You have x cubed minus 2x squared minus 5x, and then plus 6. And it says greater than or equal to 0. So I can't use factoring by grouping. That's not going to work for this problem. So I'm going to use synthetic division. I'm going to use my rational roots theorem. So I'm going to plug in factors of 6 divided by 1. I'm going to try -2 first. 1, -2, -5, and 6. Let's see. Add down, multiply across, add down, multiply across, add down, multiply across, add down. So we have a 0. One of our zeros is x plus 2. Next, it looks to me like this is all I have left is quadratic, meaning this value is my 1x squared. That's that 1 right there. This value is my x, so it's going to be minus 4x, and then I have plus 3. And so that's going to factor pretty nice, actually. That's going to be next x minus 1 and x minus 3. So you're going to have parentheses x minus 1 and x minus 3, okay? So we're going to draw our line, and we're going to do our sign pattern testing. So we have -2, we have -2, we have +1, and we have +3. So you're going to ask yourself, okay, pick a number that you want to test. So you have to pick a number that you want to test. The number that I want to test is 0, of course, 0 to 0. So 0's here, and I'm going to plug that into my equation. So I've got 0 minus 2 times 0 minus 5 times 0 plus 6 is greater than or equal to 0. So I get 6 is greater than or equal to 0. Is 6 greater than or equal to 0? So if 6 is greater than or equal to 0, then if 6 is greater than or equal to 0, which it is, that's true. So therefore, it's greater than 0, so it's above 0. So that means it's up here. And then if it's true here, that means it's not true here, it's true here, and it's not true here. So therefore, the question, as soon as you do your sign pattern testing, you're going to go back up to the original equation and you're going to ask yourself, where is my graph greater than or equal to 0? So that's the question. So it's going to be greater than or equal to 0 here between these two intervals, right? And here between these two intervals. And this interval is actually infinity. So you would say, as your final answer, you would say bracket different than parenthesis, because see, this is greater than or equal to, therefore you have to have the bracket. You have -2 to 1, bracket, union, bracket, 3 to infinity, parentheses. Okay. The next problem is another example. So this one, I think I can do factoring by grouping. So I'm going to factor out, grouping means you're going to group the first two and the last two terms. So I'm going to factor out an x squared, and I have x plus 1 left. I'm going to factor out a -4, and that's going to give me x plus 1 greater than or equal to 0. I have x plus 1, and I have x squared minus 4 greater than or equal to 0. I have x plus 1, x plus 2, and I have x minus 2 greater than or equal to 0. So I need to draw my line, and I'm going to do my sign pattern testing. So I'm going to pick my favorite number, which is 0. But first, I need to put my roots on my line. So my roots on my line would be, let's see here, -1, -2, and this gives me, this one right here gives me +2, okay? My number that I'm going to choose is 0, which is in between -1 and 2. So I'm going to put 0 here. So I'm testing that value, okay? And, you know, it's not a root. 0 is not a root. It's just a value that I'm testing, okay? So I'm going to plug it into the original equation. And my original equation is going to be 0 cubed plus 0 squared minus 4 times 0 minus 4 greater than or equal to 0. So basically, is -4 greater than or equal to 0? No, -4 is not. So therefore, this is false. It is not greater than 0. It is less than 0. So we're going to go up like this. This is going to go up. This is going to go down this way. So so that's not true. This is true. This is true. This is not true. So the question is saying, go back to the original equation, and it's saying, where is my graph greater than, above 0? So it's above 0 between these two intervals and these intervals, which is infinity. So you would say, let's see, we would say is that greater than or, yeah, it's greater than or equal to. So it'd be bracket 2 to negative 1, union 2 to infinity, and infinity always has a parenthesis. Now, that's your solution. Now, I do want to mention that we just completed a lesson on polynomial graphing, and prior to this section of the chapter. And, you are really good at that. If you've watched the videos and you've done all the work, I would say keep in mind, you can graph this. I mean, sign pattern testing is another way of solving this inequality, but you can also graph it. So think about this. This is a cubic, right? And it's a positive cubic. So that means that this goes up because it's x to the third power. The right arm up, right up, left down, right? And then you also know, so graphing that, if I were to plot this on my points, so if I didn't have a calculator, of course, right? I have -2, there's -2, I have -1, and I have 2. My y-intercept is -4, which is down here, right? And so my graph, my end behavior is up this way and down this way. So, I mean, technically, I can graph this, okay? I can do this. I can go down, come back up, and then curve around like this. And I can also look at my graph and say to myself, well, where is my graph? Again, original question, greater than or equal to 0. So you would say, here it is. There it is, greater than 0. It's above the x equals 0 axis. And here, it's greater than 0. So there's your interval, -2 to -1 and 2 to infinity. So just because we're using sign pattern testing doesn't mean that that's like the only way that you can solve this problem. These are just rules. Again, get 0 on one side, find your zeros, graph your solutions to the number line, use sign pattern testing, check to see if it's correct, etc. Okay, so let's try this one. This says x cubed minus 3x squared minus 9x plus 27 is less than 0. This one we can do factor by grouping. We can do synthetic division, but factoring by grouping for this problem is probably quicker. Maybe not. I don't know. So I'm just going to do that. So I'm going to group the first two terms. I'm going to group the first two terms, and I'm going to group the last two terms. So we're going to take out an x squared. And so I'm going to be left with x minus 3. I'm going to take out a -9, and I'll be left with x minus 3 again, which is what we want. We want that value to be the same. So we're going to take out an x minus 3. We have left x squared minus 9 less than 0. And that factors, again, x minus 3 times x plus 3, and again, x minus 3. Okay, so less than 0. So what's happening, look at this, x plus 3, and now you have x minus 3 quantity squared. So asking yourself, okay, if I were doing sign pattern testing, right, let's put this on here. I have -3 and I have +3, okay? But remember, this I actually have 2 of. So my roots, I have 3 with the multiplicity of 2. And I have -3 with the multiplicity of 1, meaning multiplicity meaning I have a square value. It's an even value. So what's happening here is that my graph is actually tangent here, and it goes through or crosses my x-axis here. So I'm going to plug in 0. So I'm going to plug in 0 because that's the number I always plug in. Plugging in 0 to my original equation, 0, 0, 0, 0. Question is going to be, is 27 less than 0? No. So this is false. So the question, so here's the thing. It's asking me, so this is a little bit different than the other ones that we did. The other ones that we've done in the prior slides have asked if the graph was greater than 0. This one is asking me, is it less than 0? So you're saying, is 27 less than 0? No, it's false. So therefore, this is not true. So it's not less than 0, it's greater than 0. So what that means is it's not less than 0, so it's not down here, right? So it's false. So that means if it's not down here, that means it's going up this way, okay? Now, because of the multiplicity here, this is going to change. This is going to change my outcome. So what I want to do is just do a quick graph and show you. Okay, you know this is a cubic. It's a cubic here, right? So my end behavior, and it's positive. So my end behavior is up, right, down, left. Okay. My zeros are -3 and 3. I also have a y-intercept way up here of 27. Okay. Keep in mind, if my zeros are only those two values, my end behavior goes up this way and it has to go down this way, right? But this, given that it's going up here, at 3, it's tangent. So what that means is can we make a better graph there? What that means is this is going up, right? So as it comes down at 3, it doesn't go through because it's tangent. So it's going to bounce off of that. It's tangent. It's going to come back up and go down like that. So now let's go to the question. The question says, where is my graph less than 0? Remember, here at 3, it's going to be bouncing off that, okay? And so my question is, where is it less than 0? So not here and here. There's my multiplicity. So it's got to go down this way, okay? So it's true here. So where is my graph less than 0? It's only less than 0 over here, because all of this and all of this, not including here because it's not less than or equal to. So over here and over here are positive. So those values are high, right? That's not less. It's asking me, where is it less than 0? So it's less than 0 down here. So it's less than 0 from -infinity to -3. And that's my answer, done. Okay. We have another problem. So this is going to be x to the third power plus 4x squared plus x minus 6 greater than or equal to 0. Factoring by grouping is not going to work for this problem. I'm going to use the rational roots theorem to try to figure out a number that will go into -6. So I would try, I don't know, let's try 3. 1, we have 4, 1, -6. Adding down, multiplying across, add down, 21. This isn't going to work. 20, the number is getting too big. So let's erase this and let's try a different number. I'm just going to try -3, okay? And so we're going to go add down, multiply across, add down, multiply across, add down, multiply across, add down. Okay, so we have a 0. We have a 0 at x plus 3 here. So to get -3, you have x plus 3. Now, I can keep doing synthetic division, or I can see this, and this is just x squared plus 1x minus 2. That comes from here. That's your x squared term. That's your positive x term, and then there's your minus 2. And this comes from starting with x cubed and then dividing by this value, which is your x minus or x plus 3. Anyway, this is going to factor to be x plus 2 and x minus 1. So let's put those here. So we have x plus 2. We have x minus 1. And I'm going to draw my line for my sign pattern testing. And my values are -3, -2, and +1. And again, I always choose 0. So I'm going to choose 0 in between here. And I'm going to plug that in. And if I plug in 0, I get 0 plus 0 plus 0 minus 6. So here's my question. Is -6 greater than or equal to 0? That's what you're asking right here. Is -6 greater than or equal to 0? No, that's a no. That's a false. It's not greater than 0. So if it's not greater than 0, it's below 0, okay? And because I don't have any multiplicity, that's minus, this is plus, that's plus, negative, minus, minus. So this is going to go like this, okay? And so you're saying, so the question is, where is my graph where's my graph greater than or equal to 0? So it's going to be greater than or equal to 0, this interval and this interval. So you're going to say, and that's a bracket, so you're going to say bracket -3 to -2 union 1 to infinity. And so that's my graph go. Can you see that? Okay. Okay, anyway, and that'll be a parenthesis. So there's my answer. And you can graph that. Again, you know that how to graph that. That's a cubic, okay? And so that being a cubic, it's a positive, so it's upright, down left. And you would put your values, -3, -2, and +1. We have a y-intercept of -6. So your graph is upright, down left, and it just kind of swings around like this. And then the question again is, where is my graph greater than or equal to 0? So here